All right, so here we have a situation. Again, we're solving one-step equations. The variable is actually in the fraction. Now, there's just a beginning step that we need to learn, but then this problem will look very similar to what we've already studied. So n divided by 10. Now, there's a rule in algebra that even though it's not written, there's an invisible 1 in front of a variable. So I'm going to go ahead and write that invisible 1 right in front there. Now, there's a trick where I can actually move the variable off to the side. So it doesn't have to be in the fraction anymore. It will just be pushed off to the side, and it looks like this. 13 equals 1 over 10 n. Now you're probably like, how do you just move off to the side? I don't get that. All right, let's go ahead and dig a little deeper real quick. So in this problem, we had 1n over 10. And really, again, it's times a number. So 1 times n divided by 10. So I could rewrite this, if I wanted to, 1 times 110 over n over 1. I could write it like that. And if I were to multiply it, again, I would get 1n over 10 or n over 10. So because the variable is on the top, if I just push it off to the side, it still means the same thing. And it makes our problem a whole lot easier to just move it off to the side for now. Now let's take a look at the rest of this problem. So we have 13 equals 1/10 n. So just like before, I need to get rid of that fraction in front of the variable, and I do that with a thing called the reciprocal. So now this will become times 10 over 1 on both sides, because the reciprocal of 1/10 is 10 over 1. So we multiply 10 over 1 on both sides. Again, I'm going to cross-reduce to make it easier on myself. So 10 goes in the 10 once, 1 goes in the 1 once. So the only thing left I have on my right side is n. Then I have 10 times 13 on the other side, which becomes 130. And there's my answer for that problem. So the tricky part was the setup at the beginning. All you have to do is push the variable off to the side and then move along forward as you would with any fraction in front of a variable.